We're given this question which says, for the table below, state the type of relationship and the connecting rule between x and y. So the functions which we commonly cover are linear, quadratic, cubic, exponential, and then reciprocal. Okay, so they're the different types which we're going to look at. So with a bit of background knowledge, if this was linear, then we look at the difference pattern and we see if it's a common difference pattern, because if it's a common difference pattern, then our rise and our run will be the same all the way through, so it's going to be going up at a constant rate. Okay, so our gradient would always be the same on that first difference pattern. So by the first difference pattern, I mean you go 4 take away 8 is negative 4, and 2.666 take away 4. Now that's not going to get you a constant difference pattern there, so it's not going to be linear. If I go to the second difference pattern, it's not going to be constant on the second difference pattern or the third. So then I go to see if it is a reciprocal, okay, or actually exponential. Now exponential is where I would go 4 divided by 8, so 4 divided by 8, and I'd see what I get, and then I would go 2.66666 divided by 4, so 2.666 divided by 4, see what that is. I go 2 divided by 2.666, and I would find that that's not constant, so that's not giving me an exponential. So I go to my last thing that I normally do would be to multiply x times y. So by that I mean x is 8, x is 1, y is 8, 1 times 8 equals 8. Then 2 times 4, 2 times 4 equals 8. 3 times 2.666 recurring, that's going to equal 8. Then we're back to 4 times 2 equals 8. 5 times 1.6 is going to equal 8. So we get a constant number when we multiply x and y together, and that's called a reciprocal. So x times y equals 8, so we write it as y equals 8 divided by x, a reciprocal function. Okay, now reciprocal will graph in our quadrants either like that or like that. It's a reciprocal function. Okay, so hopefully this is a little bit advanced because we would have already done linears and quadratics in depth and other ones. So this is just being able to find the rule for the different types, but in depth, having done the previous work on quadratics and the previous work on linears and the previous work on cubics, etc.